Hello everyone, how are you all?
Fine, so what's about you?
Yeah, same, thank you. And how was the retest?
Very good, sir.
That's great, that's great. You have given retest. Okay, just give me a few minutes to set up everything, then we'll begin. Okay, so let's begin with a problem today related to trees, okay? And then we will again move to the BST part. Some BST problems also we will take today. Able to see my screen, everyone? Okay, so let's suppose you are given a binary tree, okay? Let's suppose you are given a binary tree that is rooted at 1. This is the root. Fine. Now my task is I have to print the left view of the tree. What do you mean by left view? Whatever I can see, if I stand at the left, let's say this is my standing point at the left. If I stand here, whatever nodes I'm able to see, I will be printing them. So if that's the case, my output should be 1, 2, 5, 7, 6. Okay, this should be the output I should get if I print the left view. Okay, try to solve this problem. Think 2-3 minutes and then come up with an approach. I have to print the left view of the problem. That is, if I stand at the left of the tree, if I am standing at the left of the tree, I am able to see 1, 2, 5, 7, 9. The rest all the nodes 1, 2, 5, 7, 6. Sorry, these 5 nodes I will be able to see. Rest all other nodes I won't be able to see. All will be covered by these nodes at the edge. Okay, so you have to print 1, 2, 5, 7, 6. These nodes that you are able to see on the left edge of the tree, you have to print these 5 nodes. So come up with an approach. What do you think?
So can you please repeat the question?
Question is, this is my binary tree. I have to print the left view of the binary tree. Left view. Left view means if I am standing towards the left of the binary tree, I will be able to see the nodes 1, 2, 5, 7, 6. Rest all the nodes, whatever are there, rest all these nodes, whatever are there, they will be hidden by these 5 nodes. I won't be able to see them directly. Only the nodes that are from the root to the left edge, okay, these all nodes will be visible to me. So come up with an approach such that you will be able to print all the nodes that lie towards the left edge or that lie on the left edge of this tree. Yeah, Junaid, tell me.
सर मैंने इन ऑर्डर ट्रांसफर के इस पे थोड़ा ट्राई किया हूँ मैं
अच्छा
कि एकदम लेफ्ट वाले जो नोड सिर्फ वो ही प्रिंट किया।
अच्छा, तो क्या आंसर आ रहा है?
सर मेरा थोड़ा अलग है, मगर मेरा ट्री के सबसे बराबर आ रहा है।
मतलब कितना आंसर आ रहा है? ये अगर एग्जांपल लूं तो तुम्हारा आंसर कितना आएगा?
मेरा 1, 2, 5, 7 आ रहा है।
यहीं पे गलती है। 6 तो आएगा ना। लेफ्ट में अगर मैं खड़ा हूँ 6 तो मुझे दिख रहा है, सिर्फ 6 एकदम लेफ्ट एज लेफ्ट में है।
सर मेरा ट्री में मगर 6 नहीं है ना उधर ऐसा।
6 तो आएगा, आउटपुट में 6 जरूर आएगा।
नहीं सर मेरी ट्री में मतलब 6 जैसा एरिया है ही नहीं उधर।
ओके, तो 6 अगर लगाओगे तो क्या आंसर आएगा?
सर स्क्रीन रिप्रेजेंट करोगे एक बार?
ठीक है करो। कोड कौन सा है?
सर इन ऑर्डर है।
थोड़ा मिस्टेक है, कुछ पॉइंट मिस जा रहा है।
तब मेरे सारे लेफ्ट नोड ही प्रिंट हुए।
बट अगर लेफ्ट नोड में तो 6p आ रहा है, लेफ्ट एज पूरा प्रिंट करना पड़ेगा, तो क्या करेंगे? Any idea anyone is getting how to solve this problem?
So just a minute, I'm trying.
Yeah, sure. Take your time. At 21:20, that is 9:20, I will start discussing this problem.
हेलो
Yeah, tell me.
सर हम लोग एक एक लेवल चेक कर
ठीक है, फिर
हम राइट पार्ट को ट्रैवर्स ही नहीं करेंगे, लेफ्ट पार्ट को सिर्फ ट्रैवर्स करेंगे, एक एक लेवल चेक कर लेंगे।
ठीक है, फिर क्या करेंगे? Okay, so one hint I would like to give. Can I say that my left view answer will be first node of each level? Will it be correct? First node of level 1 is 1, printed that. First node of level 2 is 2, printed that. First node of level 3, 5, printed that. First node of level 4, 7, printed that. First node of last level 6, printed that. Will it be a correct logic? Will it be a correct logic?
सर यही तो बता रहे थे, ऐसा नहीं कर सकते।
तुम्हारा आवाज बहुत कम आ रहा है, मतलब
सर यही हम बोलना चाह रहे थे, ऐसे लेवल हम ट्रैवर्स करके करवा सकते हैं।
ठीक है, सही है, पर इसको इम्प्लीमेंट कैसे करेंगे?
ठीक है सर, थोड़ा कोशिश करता हूँ।
ठीक है, take 2 minutes more, not more than that I will give. Nobody is getting the answer how to do it. Any? This is again a very important problem. If you can solve this, you can solve the right view part also. Any idea you have got? Tell me. The hint that I have given. Okay, one thing. Let's start from the root. See here.
Sir, first we have to give 1, 2, 5, 7.
Yeah.
Again 5, 6, 6.
Why 566?
Going from left side to right side.
But I said only the left view will be printed. This part. From 1, 2, 5, 7, 6. Nothing else you will be able to see if you are standing at the left of the binary tree. Okay. Just this part is the left view of the tree. 1, 2, 5, 7, 6. Whatever is lying at the extreme left of the tree, all those nodes that are lying at the extreme left of the tree, that is 1, 2, 5, 7, 6. Those will be part of my answer. Okay. Okay, fine. Let's start our traversal from the root. Let's start our traversal from the root. Okay, so root will be part of my answer. Root will be part of my answer. Whatever answer I have printed here, root will be part of it. Let's print the root. Let's print the data of the root. Print it. Okay, now tell me. There is a left child, there is a right child. Which one I should be able to see if I'm standing at the left?
Left view.
Sorry? Left child I will be able to see, right? Because I'm standing at the left, my eyes will be go on hitting here. And this particular thing will be hidden by this node. This node 2 will be shadowing the node 3 part. Okay, so I won't be able to see this node because of presence of node 2. Fine. This is the logic. Now see, if I am standing here, I will be able to see this node. So if right now I have printed one, I should go to the next level. To the next level of nodes, I should go to. So if left child is existing, shall I print that or shall I go to the right child? Which one shall I do? If node 2,
sir.
Left side.
if node 2 is
Sir?
shadowing, yeah, tell me.
Sir, are you doing in order traversal?
No matter here. Let's focus on what we want to do here, because there will be slight changes in order traversal. There will be slight changes. Logic is correct, but yeah, how will you manipulate that? That depends. Now tell me, I am standing at the root. I know that, okay, if my left child is existing, if my left child has some data, it will be what? Shadowing the right child. So I don't need to see this because I can't. So what will I do? If I'm standing at the root, will I go to the left child or the right child? Which one shall I do for the next level?
Left child will do.
Okay, so if my left child is existing, I will go to the left child because my left child will be shadowing the right child part. Whatever is content of the right child, that will be shadowed by my left child. Fine. So let me come to the left child and then let me print it. Whatever data is, let me print it. Okay, fine. Now what will I do? I am standing here. There is no right child. Only one left child this node has, right? No need to means I don't have any choice that okay, right child also is there, left child also is there. I just have one choice. Left child is there. Let's go there and print the data. Now again, once I'm at 5, what should I do next? Again, I have two child nodes, left and right. What shall I do now?
Go for left child.
Shall I go for left or right? Because again, if the left is existing, it will be shadowing the entire right part, right? It will be shadowing the right child part. So definitely I cannot see whatever is beyond 7. My eyes are blocked here. My eyes are blocked by wall of node 7. So I cannot see whatever is beyond 7. So let me go here at the 7. Fine, and print it. Okay, now tell me what will happen. No left child is there. So if I am standing at the left of this tree, can I see this node 6? Can I see this node that is the right child of 7?
Yes, we can.
Right? So if no left child is existing, I will be able to see the right child of my current node. So now I can go to the right child and can print it. Okay, fine. Let's take another example related to this. Let's say this is the root 3. Okay, tell me what should be the answer. If I am standing here at the left of this binary tree, what should be my answer?
Sir, 1, 3, 4, 6, 7, 9.
1, 3,
4,
4. Next,
6,
6,
and 7, 9.
7, 9, right? How will I get this answer? Any idea? First node of each level. How shall I do this? First node of level 1 is 1. First node of level 2 is 3. First node of level 3 is 4. First node of level 5, level 4, sorry, is 6. First node of level, what level it is? Level 5 is 7. First node of level 9, level 6 is 9. So that's why all the first nodes of their respective levels are my answers. How shall I do this? What do you think?
Sir, if the root have 2 child, then we print the left child. If no, only one child, then we print this one only.
Means what we will do here? What do you think? What we will do here? How can I know that right now, whatever node I am visiting is the first node of my level, is the first node of the level that I am visiting? Initially, I am at root. So I am at level 1. This is the first node of level 1. Print that. Then come to the level 2. First node of level 2 is 3. Print that. First node of level 3 is what? 4. Print that. First node of level 4 is 6. Print that. First node of level 5 is 7. Print that. And then first node of what? The last level is 9. Print that. What we will do here? How can I build the logic? Tell me something.
सर अगर लेफ्ट है तो लेफ्ट प्रिंट करो, नहीं तो राइट प्रिंट कर दो.
अच्छा, ये यहाँ पे काम करेगा? तुम्हें क्या लगता है? ये तो चलो प्रीवियस में ये लॉजिक काम कर रहा था. लेफ्ट है तो लेफ्ट प्रिंट करो, नहीं तो राइट प्रिंट कर दो. बट व्हाट अबाउट दिस?
सर इधर भी सिमिलर ही रहेगा, मतलब इधर जहाँ पे एक नोड है वो एक प्रिंट होगा, फिर लेफ्ट राइट आ जाएगा तो पहले लेफ्ट को कंसीडर किया जाएगा.
ठीक है, फिर
सर ऐसी एक नोड है तो एक प्रिंट होगा, अगर लेफ्ट राइट है तो पहले लेफ्ट को कंसीडर किया जाएगा.
अच्छा, फिर
सर फिर हो जाएगा ना मेरे ख्याल से.
okay, first see, as per the logic, if I am at root, I will print the root. Whatever is the answer, root will be definitely part of it. Okay. Now, if left child exists, I will go there. If the left child exists, I will go there. Print that. Okay. No left child. Then, if no left child of a node is there, I will go to the right. Print that. Okay. Now next, if left child exists, I will go there. 6. So the traversal is stopping here. If left is existing, I will go there. Else, I will go to the right part. But as per this logic, I am getting half answer only. 1 4 1 3 4 6. The 7 9.
Sir, we can do like this, no sir. We just make a maximum level, and in that we can print the first. Every time maximum level will be changed with the level.
Means what will you do so that you will be knowing that okay, this particular node is the first node of my level.
सर नन चेक करेंगे.
क्या
सर
नन
ये हो
check
सकता है
करोगे?
कि इनका पूरा सर डेप्थ जहां तक जा रहा है वहां तक इसका प्रिंट कर दे सर, लेफ्ट वाला.
वही अभी तक चलो बहुत अच्छा तुमने ऑब्जर्वेशन किया है. जब तक डेप्थ जा रहा है लेफ्ट प्रिंट करते जाओ, पर अगर लेफ्ट है ही नहीं तो फिर क्या करेंगे? राइट जाएंगे.
यस सर.
लेवल डिसाइड करेंगे. लेवल में अगर हमारा लेस देन 0 रहेगा तो प्रिंट रूट डेटा, अदरवाइज ऐसे करके प्रिंट करना पड़ेगा उसको, और लेवल को 1 से इंक्रीमेंट करते जाना पड़ेगा.
गुड आइडिया.
एंड सर ग्रेटर देन ये भी हो सकता है सर, बड़ा उससे.
Okay, but how will I know, man? How will I know? Let's suppose I am initially at this root, right? I am initially at this root. And right now this is at, let us initialize a variable. Let us take a variable level. Initially I am at level 1. Okay. Level 1. This is what I am at level 1, haven't printed anything yet. So let's do what? Start the printing. Print the root. Print it. Okay. Then increase the level, that now I will be going to level 2. Only one node per level I will be printing, right? The first one only. Now increase the level and go towards its left child, because the left is existing. Go to the left. Print that. Now again increase the level. Okay. Now whatever I will be printing will be from level 3. Level 2 part is done. Right child is existing. Print that. Again increase the level. Now whatever I will print from level 4. Left child existing, print that. Okay. Now again increase the level, that I have to print something from level 5. What will I do at this point? Once I am coming to 6, what will I do here?
सर लेफ्ट वाला राइट के जो ग्रेटर हो वो प्रिंट हो जाए.
समझा नहीं.
सर 6 प्रिंट
बार-
करने
एक
के
बार
बाद
repeat-
उसका
repeat
लेफ्ट राइट
कीजिए
नोड
आप।
भी नन चेक करें।
देखो।
आपका क्वेश्चन रिपीट कीजिए सर।
See, level. Once I'm
Level-
stopping at this 6, what will I do here? This is my concern.
लेवल तो वैसे भी इंक्रीज होगा ना सर। 6 आपने प्रिंट किया, लेवल से वैसे भी इंक्रीमेंट होगा।
ठीक है, लेवल इंक्रीमेंट होके 5 हो गया। फिर मैं क्या करूंगा? फिर तो मैं लेफ्ट पे हूं ना, यहां से तो और कोई पाथ ही नहीं है 7 जाने का, वापस जाना पड़ेगा। कैसे करेंगे ये? 6 पे राइट नाउ आई एम स्टैंडिंग हियर, दिस माय रूट इज स्टैंडिंग एट द सब ट्री ऑफ 6. What will I do such that I will go to the next level of nodes, this 7 and 9? What will I do? What do you think? Any ideas?
सर इन ऑर्डर में कैसा लेफ्ट से पेरेंट और फिर राइट में जाते तो वैसे कुछ रहेगा क्या?
कुछ सोचो क्या करेंगे in
Here
order
where
level को?
recursion will happen. So we will again go to the root value and we will check for the left values.
We will again check for the right values, as in something you are asking. That okay, the left part is done. I have to check for the right also, that okay, some part is possible there or not. But yes, something I have to keep, right? Something I have to keep to mark that okay, this particular node is of this level. What will I do there? I have to mark, right?
Yeah, then we will create a variable in that we will always make changes with the level value. That will help more.
सर लेफ्ट और राइट को कंपेयर करके चले तो
क्या क्या कैसे करोगे? ये लेफ्ट और राइट को कैसे कंपेयर करोगे? कुछ बात है कि मुझे आफ्टर कमिंग हियर, वंस आई एम स्टॉपिंग हियर, आई हैव टू कम बैक टू इट्स पेरेंट 4. Then if I go to the right child subtree and then from the subtree of 5, if I go to 7, I will get my next answer 7 and 9. Something like this should be done to solve this problem. But what shall I do?
सर इन ऑर्डर में जो रिकर्जन यूज करते थे ना वैसे रहेगा क्या?
हाँ, वैसा ही रहेगा कुछ. Something like that will be there. Anything using dictionaries we can do? What do you think? Anything using dictionaries we can do? Hashing.
यस सर।
What?
सर जैसे एक एक नोट पास करेंगे उसको डिक्शनरी में ऐड करते रहेंगे।
नोट पास करने से क्या होगा?
जैसे अगर जो भी नोट पर अगर नन रहा तो प्रीवियस नोट से उसके प्रीवियस नोट का राइट चेक करेंगे।
कॉम्प्लिकेटेड हो जाएगा प्रोसेस, बहुत कॉम्प्लिकेटेड हो जाएगा।
सर हो सकता है ना सर, जैसे कि 4 के नीचे सर कंपेयर करें सर लेफ्ट और राइट से, जो बड़ा है सर वो लिख दें, मतलब
बड़े छोटे से क्या होता है?
सर हमको तो यही लग रहा है सर।
लेफ्ट व्यू, अगर मैं लेफ्ट पे खड़ा हो गया, इफ आई एम स्टैंडिंग एट द लेफ्ट, लेट्स सपोज, then I will be able to see how many nodes. This should be my answer. see one thing, one approach I am giving. Let's take the tree something like this. One, 3, 4, 6, 5, 7, 9. Let's keep a dictionary. Let's keep a dictionary. Initially, I am at the root. So which level I am at right now? Initially, I am at the level 1, right? Okay, now check. Anything has been printed from the level 1 yet? Any node has been printed from the level 1 yet? What do you think? Anything I have printed from the level 1 yet?
Yes, sir.
Have I printed anything yet? This is the output. Let's say my output is empty right now. I am at the root. I am right now standing at level 1, and this is my dictionary. This is my dictionary. Anything I have printed from level 1?
No, sir.
No. So do one thing. Whatever node I am standing at, print that. Print it. Now increase the level. Sorry. Insert this level. Okay. Insert this level as the key inside the dictionary. Okay. And one node from this particular level 1, I have printed one node. Okay. This will be the status of my dictionary right now. Fine. Okay. Now only one node is possible to be printed from a level. Am I correct? As per the left view, only one node, that is the first node of a level, I can print. Nothing else I can from a level. Okay, so let's increase. Let's go to the next level, increase this variable's value. Let's go to the next level. Now, where can I go? What do you think? If I'm at the root 1, where can I go next? Only one child is there, that is the left child. Let's shift my root and let's go to the subtree of 3. Okay, now tell me, anything from the level 2 has been printed yet?
No, sir.
Anything from the level 2 has been printed yet? So let's print whatever node I am standing at, print that. Print it and insert that. Okay. Level 2. From level 2, I have printed one node. Let's keep this status inside the dictionary. Okay, yet again, what shall I do? What shall I do? Only one child I have of 3. Let's go to the subtree of 4. And let's increase the value of level that I have right now. Okay, tell me now. Anything from level 3 I have printed yet? Anything from the level of 3? From the level 3, any nodes I have printed? Is it true?
No, sir.
So let's print whatever node I am standing at. This is the first node. I will be printing that. Print it and then insert into the dictionary that, okay, from level 3, I have printed one node. Done. Okay, now tell me, the level will be increasing by 1. Anything from level 4 I have printed, where shall I go? If the left child is there, my preference will be, okay, I will be going to the left child first. I will be going to the left child first. Let's go to the subtree of 6. Now, okay, anything from level 4. Print it. Now next, what shall happen? All the subtrees are gone, right? No subtrees of node 6 is there. What shall I do? Return to its parent node here. Okay, now let's start exploring. Since the right child is existing, let's start exploring that. Okay, is there any possible answer from the right subtree of 4? Since I have gone back to 4, let's decrease the answer by 1, 3. That, okay, right now I am standing at 4, right? I have came back to 4, I am standing at 3. Level 3. Check inside the dictionary again. Level 3 has been already printed. One node from the level 3 has already been printed. I can print nothing from this level again. Okay, I can print nothing from this level again. So, okay, a right child of this node is existing. Let's go there and see whether any possible answers are there from there are there or not. Okay, let's go there. Okay, now I am at the subtree of 5 and increase our level by 1, 4 again. I am at 5. Its level is what? At level, it's present at level 4. Okay, I think we have printed level 4, 6. Okay, so one node from level 4 is also printed. So see, inside the dictionary, level 4's one node has, it is marking that, okay, from level 4, one node has already been printed. So no need to print any other node from the level 4. So only one now, only one node, only one child of 5 is present, that is 7. Let's go to its subtree. And let's increase the level by 5. Now tell me, is there any node that has been printed yet from level 5? Level 5 has been printed. Any node from level 5 that has been printed?
No, sir.
So let's print that. First node I have visited from level 5, print that, 7. Okay, mark inside the dictionary level 5. From level 5 I have printed one node. Done. Okay. Now increase the level, that okay, 5 has been done. Let's go back to 6. Let's go where? Let's go to level 6 and check whether any node is there or not, and we can print or not. Only one child. Let's go to the left. Now I am at a subtree of 9. Okay, which is, I have visited my first node from this level, right? 9 is the first node that I have visited at level 6. Print that. And insert that, okay, from level 6 also I have printed one node. This part is done. Anything, any level else that I have that I can visit? No, right? So using this dictionary, I can store that, okay, how many nodes I have printed from each level. Okay, from each level, how many nodes that I have printed, I can store it inside the dictionary. If while visiting any other node, while visiting any node, I will check what is the level of it. What is the level of it? At what level it is storing? It is staying, and whether any node from that level has been printed or not. If any node from that level has been printed, I will just keep on exploring to the I will go to the next level and keep on exploring whether any possible answers are there or not. Fine. If no node from that dictionary, sorry, no node from that level has been printed, so dictionary won't be storing that level as key. Dictionary won't be storing that level as a key. So I will, so that means if dictionary isn't storing any key of that level, that means right now at whatever node I am, that is the first node of my that level, print that. That should be the logic we will be utilizing to solve this problem. Yeah, Junaid, tell me.
सर लास्ट में जब 9 पे आएगा तो सर उसके बाद वापस 7 पे जाएगा ना, क्योंकि वो पेरेंट पे जाएगा, फिर देखेगा राइट में कुछ नहीं तो जब जाके स्टॉप होएगा ना।
मतलब फिर तो बैक ट्रैकिंग रिकर्शन में तो फिर फंक्शन कंप्लीशन हो जाता है ना, फिर तो प्रीवियस फंक्शन पे जाता ही है। तो इसीलिए तो स्टोर कर रहे हैं बाहर, इसीलिए तो स्टोर कर रहे हैं कि लेवल में प्रिंट हुआ है या नहीं, इस लेवल में कोई नोट है जो प्रिंट हुआ है, अगर हुआ है तो और प्रिंट करने की जरूरत नहीं है, ठीक है। और अगर नहीं हुआ है, दैट मीन्स 100% आई कैन से ओके, right now whatever node I am standing at, that is the first node of my current level, and I will be printing that.
सर 5 वाला फिर से रिपीट कर दीजिए सर।
Okay. See, this was my root where I was standing. After printing 6, no subtrees of 6 are there. Both are none. No subtrees of 6 are there. It will go back to its parent node. Okay. Now see, once after printing 6, what is the state of my dictionary? Level 1, there is one node. Level 2, one node. Level 3, one node. Level 4, one node. From the first 4 levels, I have successfully printed 1 nodes. That is 1, 3, 4, 1, 3, 4, 6. These 4 nodes. Now see, no subtrees of 6 is there. It will go back to 4. Now 4 has a right child. 4 has a right child. I will go to the right subtree of 4 and keep on exploring whether any possible answers are there or not. These 7 and 9 are possible answers, right? I have to see that also. So, okay, let's go to 5. Let's go to 5. This 5 is at what level? Level 4. Okay, now I will check inside the dictionary. I will check inside the dictionary. Any node that has been printed from level 4. So 1 node has already been printed. No need to print any other node from this level. Go back, go to the next level. Go to the next level, that is level 5. Only 1 node is there inside level 5. So now I will check. Once I am at level 5, I will check inside the dictionary. Any node I have printed from level 5? No. So that means wherever I am standing, this is the first node of my level. 100%. Print that. Print it. Insert that. Insert the level as the key. And mark 1. That okay, 1 node from this level I have printed. Okay, now what will I do? Go to the next level. Go to the next level. Level 6. Printed anything yet? No. How can I see? Check the dictionary. Any level 6 nodes I have printed? No. So do what? Print this 9. Print this 9 and insert a key 6 inside this inside the dictionary. I mark that okay, 1 node from level 6 I have printed. This part is done. So this is how I will solve this problem. First thing, tell me, have you got the logic, what we are using and how we are solving this problem? Don't stay quiet, please. Don't be in a pin drop silence mode. Have you got the logic? This is a very important problem.
Yes, sir.
Only one person has got. Rest?
Yes, sir.
Got it, sir.
Sure.
I got it, but how to code?
That's your part. You will code it first, then only I will show you the code, how to do it. First, all of you try how to code this problem. This is your homework for today. Come up with a code. How will you implement this problem? If you don't code it tomorrow, if no one gives me any answer, that okay, try. If you fail, no problem. I will take it tomorrow, but you have to try. If you don't try, I will not show. You have to try. If I don't invoke the trying thing inside you, you won't be able to do anything in your interviews.
सर एक बार फिर से क्विक रिवीजन दे दो.
चलो एक और एग्जांपल लेते हैं, ठीक है. Okay, initially the dictionary is empty. Right now I am at root 1. What is my current level right now? 1. Anything from, and right now my output is also empty. Right now my output is also empty. Anything from level 1 that I have printed, first tell me that. Anything from level 1 that I have printed?
No, sir.
So what to do? So that means wherever I am standing is the first node of my level. Am I correct? Wherever I am standing right now, that is the first node of my current level. True or false?
True, sir.
Right? Print that. And that okay. Insert level 1 as the key and its value 1. That okay. From this level, I have printed 1 node. Done. Okay, now tell me. Right child, where should I go first? So should I go to the right child or should I go to the left child? Where should I go first? Let's have some twist here. Okay, this should be our new tree. I have a left child and I have a right child. Where should I go first?
First, we have to go left side.
Yeah, so let's go. Let's first explore the left subtree. If I am standing at the left, right? First things that I will be able to see are the left nodes, right? If all the nodes from the left edge are successfully printed, then only I can say that, okay, then only it is fruitful to me to go to the right subtree and see whether any possible nodes are there, which can be my possible answers, right? Okay, fine. Okay, now let's go to the next level. I am at level 1. Let's go to the next level. Level 2. And from inside level 2, where should I go first? Into the left subtree. Into the left subtree. Fine. Okay. So now from level 2, I have printed anything yet? Printed anything from level 2 yet? I am into the, so let's print. So is it guaranteed wherever I am standing is the first node of level 2? Right now I'm at 2, right? It is the first node of level 2. Is it guaranteed?
Yes, sir.
Right? Okay. Print 2. Insert key 2 and that, okay, from level 2 I have printed one node. This part is done. Now next, what shall I do? Next, what shall I do? Tell me.
Go to the next level.
Okay, let me go to the next level. But where? Level 2 I am inside. I have to go into the next level. Where should I go first? Left subtree or right subtree?
So let's left subtree.
So only one child is there. So only left subtree exists. Let me go here. Okay, fine. Next, what will I do? Anything from level 3 has been printed? Anything has been inside from level 3 has been printed?
No.
No, sir.
Okay, let's print. So am I saying correct that, okay, right now, wherever I am standing is the first node of level 3. Is it true? If I watch out from the left, if I see from the left, right now, wherever I am standing is the first node of my level 3. Am I correct?
Yes, sir.
Okay, so let's print that. Printed, insert key as 3. Okay, from level 3, I printed one node. Now what shall I do?
Yes, sir.
Now what shall I do? Level 3 part is done. Now what shall I do?
Go to level 4.
Go
Go to level 4. Okay, fine. Now I can go to any left subtree of 4, true or false?
Yes, sir, but there is none.
False.
Left is not exist now. That's why.
Okay,
we
so
move
I have to go
right.
to, okay, right.
Right.
So I will go to the subtree of 5, right? Level 4. Inside level 4 I am. Anything I have printed from level 4, true or false? Anything I have printed from level 4 yet?
No.
False. No.
So is it, am I saying correct thing? Right now, inside the dictionary, no key equal to level 4 is there. So I can say wherever I am at node 5. This is the first node from the left. That is at level 4. Am I correct?
Yes, sir.
If I see from the left, this node 5 is the first node of level 4. Fine. So do what? Print 5. Next, insert 4 as the key and mark that one node from level 4 I've printed. Now what will I do? Now what will I do?
So return.
Yeah, definitely, right? No subtree of 5 is there, no left or right child. So let me return to its previous node. Okay, anything? Or now if I am at 4, my level is 3. Am I correct?
Yes.
Okay, now go. Okay, from this 4, anything I am left with? Anything else I can do?
No, sir.
No, sir.
Okay, now go back to. If I am at 2, my level is what?
2.
It's 2.
Okay, 2. Okay, fine. Now anything left for 2 to do?
No, sir.
Okay, go back to
No.
1, right? Go back to 1. Okay. If I am at 1, what is my level? 1. Fine. Anything, any subtree of 1 that is left to be explored, that any possible answer from that subtree is there.
Yes,
Where
sir.
is it? So
Right
I can
side.
go to the right subtree, right? Right subtree of 1. Okay, fine. Let's go there. Let's go there. This entire part is left. I haven't seen it or explored this part. Let's go here. Now root is at 3. I am at the subtree of 3. What is my level?
2.
2. Okay, now see. Anything from level 2 already printed in? Anything
Yes,
from
printed.
level 2 already printed?
Yes, sir.
So I do.
Yes, sir.
I need to print something from level 2. Is it true?
No, sir.
No? Okay, let's go to the next level. Let's go to the next level. Let's go here. This is the subtree, left subtree of 3. Fine, done. Okay, fine. What is the level? If I am at 7 right now, what is my level?
3.
3. Anything from level 3 that is already printed?
Yes, already printed.
Already.
Yes, sir.
I need to print anything else from level
No, sir.
level 3?
No, sir.
Okay, fine. This 5 is also at level 4, right? So 5 will be, I guess, shadowing this part. Let's take another node here. 10. Okay, fine. So let's go to the next level here. Now tell me anything from, so if I am at 9, what is my current level?
4.
Something already printed from level 4?
Yes.
Anything to be done here at 9?
No, sir.
Right, this actually what is happening, the picture will be something like this. 5 will be at the level of 9. Okay, this is, I have drawn it quite above. 5 will be at the level of 9. So when I am standing at the left, this 5 will be shadowing the part of 9. Okay, so I won't be able to see 9 from the left view. Fine. Okay, I don't need to do anything at 9 right now. Okay, anything else left? Any subtree of 9 that I haven't seen yet? Any subtree of 9 that I
Yes,
have?
sir.
Okay, fine. Let's go there. What is the current level? If I am at 10, what is the level 5? Okay. Now tell me. Level 5, anything has been printed inside the, as a output from level 5? Anything has been printed?
No, sir.
Okay, fine. So we can print this node because this is the first node of my level. We can print that. And let's insert 5 as the key. Okay, anything is left? Anything is
sir.
left to be done? Return to its parent. Anything is left for 9 to do? No. Return to its parent. Anything left for 7 to do? No. Return to its parent. Anything left for 3? No. Return to its parent. Anything is left for 1? All the subtrees are seen. Everything is done. Return to the position from where you have been called. That's all. This will be the final output. 1, 2, 4, 5, 10. Come up with a code tomorrow. Try. Don't fear of failing. Okay, that I am not able to do that. Don't fear that. Try whatever method you can do. Then we will take the code. This is the logic of program. Now tell me, how many of you don't understand this? Simple pre-order traversal is there, nothing else. Simple pre-order traversal. How many of you didn't get it? Please tell me. Don't be silent, please.
Got it, sir.
Only you are telling, brar. Nobody else.
Got it, sir.
Yes, sir.
Very few people are telling. Let rest pin drop silence.
Clear, sir.
Yes, sir. Got it.
Okay, fine. Let's go over to our next topic, that is BST. Okay, I guess we have discussed the part of insertion in BST. Am I correct? How do we insert in a BST?
Yes, sir. So 4 properties we have discussed.
Okay, yeah. So let's take the code insertion in BST, right? Let's take the code of how we insert things inside a BST. Okay, 1, let's say this is my current BST. Okay, sorry. 5. Okay, if I want to insert 4, where it will be going?
Left of 5.
Left side, sir.
Why to the left child of 5? Why?
Because
Sir, it is
Because
less
it's
than
less
5.
than root.
It is less than root. Okay, fine. If I want to insert, if I want to insert 3, where it will go?
Left of 4.
Left of
Why
4.
left of 4? Why left of 4?
Because
3 is less than
Less
4
than
and
4.
also less than 5.
So if I want to insert, I have to start from the root. 3 is less than 5. So 3 should be at the left subtree of 5. Correct or wrong?
Yes, sir.
Okay, fine. So let's go to the left subtree of 5. Let's go to the left subtree of 5. Okay, again, see, one node is there. 4. Any child, left or right child, it is having. 4 is having any left child, right child, something like that.
No, sir.
Okay, so 3 is less than 4. So create a node here, insert the left child. Insert data into the left child. Done. This is how I am inserting. Okay, now let's say, okay, if I want to insert 4 again, what will happen?
Sir, not possible.
Not
Because
possible.
duplicates are not allowed.
So how shall I check that? How shall I check that? I will start the insertion from the root. Am I correct?
Yes, sir.
Okay, from the root 5 less than 4. Sorry, 5 is greater than 4. So inside the left subtree of 5, this 4 will be lying. Correct? Okay, let's go to the left subtree. 4 is equal to 4. Correct or wrong? So where should it go? Into the left or right subtree? Where? Not possible. Left right subtree of 4 will be having greater values than 4. Left subtree of 4 will be having lesser values than 4. Correct? So this 4, since is equal to 4, so it cannot be going into any place, into the either of the right subtree or left subtree. No place is possible. So what will happen from here? I will return not possible. Okay. Not possible. Fine. Okay, now let's say I want to insert 6. What will let's say I want to insert 10. What shall I do?
It's right side from the
Right.
5.
Okay, now tell me the whole process. Tell me the whole process.
Sir, first check root. If root is greater, sorry, element
What
is
was my
greater
tree?
than root.
5, 4, 3, right? Okay, so initially I'm standing at the root. What shall I do? What shall I do?
सर वो चेक करेंगे कि रूट से 10 बड़ा है या छोटा है, तो बड़ा है तो वो
Okay.
राइट साइड है.
So it's greater than 5. In what subtree of 5 10 should be lying? Tell me that. Right subtree. Any node towards the right subtree of 5, is it there yet? Okay, so do what? Make a right child and assign the value 10 there. This part is done. Fine. Okay, now let's say I want to insert 7. What shall I do? I want to insert 7. What will happen?
सर 5 से चेक होगा वो पहले रूट से, फिर वो हो जाएगा 10 में. 10 से चेक होगा तो वो लेस देन 10 है, तो वो 10 की लेफ्ट साइड होगा फिर.
Okay, see. So root is at 5. I want to insert 7. 7 is greater than 5. Correct or wrong? At what subtree of 5 7 will be lying? Tell me.
10.
Right.
Right subtree, right? Right subtree of 5. This 7 will be lying inside, right? Okay, fine. So let me come to the right subtree of 5. Okay. Now tell me, 7 is lesser than 10. Am I correct or wrong?
Yes, sir. Left
So what
subtree
subtree of 10? Left subtree of 10, 7 will be going inside. So no node is inside the left subtree of 10 yet. Let's make a node and let's insert the data to be 7. Done. Okay, now let's say I have date. I have node 9 to be inserted. What will happen? Tell me. I have node 9 to be inserted. What will happen?
Right subtree of 7.
Okay. Tell me the whole process. Somebody else. What will happen? I am starting at the root. 9 is greater than 5. Right subtree of 5, 9 should be inside. Okay, let's come to the right subtree. So 9 is lesser than 10. 9 is lesser than 10. Inside the left subtree of 10, 9 will be inside. Okay, let's come to the left subtree of 10. 9 is greater than 7. 9 is greater than 7. All right. So inside the right subtree of 7, 9 will be lying. Getting the point? How will we do the insertion part? Tell me that.
Yes, sir.
No, sir.
Yes, sir.
Yeah, tell me. Memon, what is the problem?
सो यहाँ पे 7 and 9 वाला नहीं, थोड़ा डिफिकल्ट, थोड़ा मतलब डाउट आ रहा है, वो एक्सप्लेन कीजिए।
ये देखो स्टार्टिंग रूट से देखो, स्टार्टिंग फ्रॉम द रूट 5 से ग्रेटर है 9, 5 से ग्रेटर है 9,
नो सर।
9 5 से ग्रेटर नहीं है।
राइट साइड, यस सर, सॉरी।
तो सो इनसाइड द राइट सब ट्री, तो 5 के राइट सब ट्री के अंदर 9 जाएगा, ट्रू और फॉल्स?
ट्रू सर।
ठीक है, तो चलो राइट सब ट्री के रूट पे आ जाते हैं 5 के। ओके, नाउ टेल मी 10 से 9 छोटा है, करेक्ट और रॉन्ग? 10 से 9 छोटा है, करेक्ट और रॉन्ग?
करेक्ट सर।
सो 10 के कौन से सब ट्री में जाना चाहिए, राइट और लेफ्ट?
लेफ्ट।
क्योंकि छोटा है तो लेफ्ट सब ट्री में जाएगा, राइट?
यस सर।
सो ऑलरेडी एक नोड है, देखो लेफ्ट सब ट्री में ऑलरेडी एक नोड है, तो मैं यहाँ आ गया 7 में। नाउ 7 से ग्रेटर है या छोटा है 9?
ग्रेटर है सर।
तो उस 7 के कौन से सब ट्री में जाना चाहिए 9 को?
राइट साइड।
राइट, इसीलिए आ गया राइट चाइल्ड में। दैट्स ऑल, नथिंग एल्स, जस्ट कंपेयर द नोड्स, कंपेयर द
Hello.
नोड्स। या टेल मी।
सर हम एग्जिस्टिंग नोड को रिप्लेस नहीं कर सकते सर?
हमारा आवाज कम आ रहा है कानू। हेलो
सर हाँ सर, मैं बोल रहा था कि सर 7 नोड एग्जिस्ट है, तो हमने 9 को उसका राइट में लिए, हम 7 को और 9 को ऐसा रिप्लेस नहीं कर सकते, 9 वहां पे इंसर्ट कर दे और 7 को मूव कर दे?
वो दूसरा केस है, फिलहाल सिर्फ मैं बीएसटी का इंसर्शन देख रहा हूँ। बीएसटी में एग्जिस्टिंग जो नोड है मुझे उसी के अकॉर्डिंग काम करना पड़ेगा। तुम जो कुछ कह रहे हो वो कुछ फीचर आता है हाइड बैलेंसिंग बीएसटी में, दैट्स अ डिफरेंट इशू, दैट्स अ कंप्लीटली डिफरेंट इशू।
ऐसा होता है क्या सर?
एक सर्टेन कंडीशन आता है, तब क्या करते हैं कि दूसरे काइंड ऑफ ट्रीज में हाइड बैलेंस करने के लिए कुछ चेंजेस करते हैं, ठीक है? दैट इज नॉट द केस विद बीएसटी। अगर नोड एग्जिस्ट होता है मैं उसे देखूंगा कि उसका राइट लेफ्ट में जाएगा या राइट में जाएगा, ये मुझे देखना ही पड़ेगा। रिप्लेसमेंट नहीं हो पाएगा, डिलीट कर सकते हो नोड, बट डिलीशन इज डिफरेंट, डिलीशन इज कंप्लीटली डिफरेंट। ओके,
क्योंकि वो पूरा निकल जाएगा ना, मैं क्या बोल रहा था कि रिप्लेस करके उसको वैल्यू।
नहीं ऐसा नहीं होता, ऐसा नहीं होता, ऐसा नहीं होता। ठीक है, सो लेट्स कोड इट, लेट्स कोड आवर बीएसटी, हाउ टू इंसर्ट इनसाइड आवर बीएसटी। Okay, so this is my right now, this is the tree that I have. So ऐसे तो काम चलेगा नहीं, right? अब तो कुछ भी ट्री नहीं बना सकते, am I correct? Inside BST we have to have some rules, right? Such kind of tree making will not, random tree making will not be there, am I correct?
Yes sir.
Yes sir.
Okay, so okay, yeah, let's keep it. I think all the codes you have got from my end. Entire codes you have got from my end regarding to the trees. I think I have updated the file on the repo.
Yes sir.
Got or not? How many of you haven't got? I think one student was asking that where is the repo link? Okay, fine. This part is done. Okay, class is there, same class we can use or not? One data will be there and 2 left and right child nodes will be there, child links will be there, am I correct?
Yes sir.
Okay, fine. So let's let's define an insertion function, def insert. Okay, def insert, and inside this what do you want to give? Data only, right? Okay, well, 2 things will be required. One is the root, what is the current subtree root I am inside, and what is the data I want to insert. This is it. So okay, tell me, okay, first thing, tell me, if there is no node inside the tree, if there is no node inside my tree, what shall I do? Tree is empty, nil, nothing is there inside the tree.
So return.
Can I do one thing? If there is no node inside the tree, there is no node inside the tree, can I make one and assign the root here and insert the data here only to be some data D, let's say. Can I do something like this? Root is empty. I want to do some insertion. So what will be happening? I will be making a node with data D, and this node will be the current root of my tree. Can I do this? If the entire tree is empty and I want to insert a node, that will be the root of my tree or not? Tell me. Again, a pin drop silence.
सब explain करेगा वो.
सर एक बार रिपीट कीजिए.
Sir, repeat करना please.
Tree is empty. Entire tree is empty. The first node I am entering inside the tree, will that be the root? Tell me that.
Yes, sir.
Right? That is what I'm asking. If the tree is empty, the first node that I will insert will be the root of the tree. So how will I do this? Initially, root equal to none. Initially, root equal to none. Now what shall I do? Tell me. Initially, the root equal to none. What shall I do? I should check, right? If root equals to none, do what? How can I make
Return root.
No. Why will I return root here? I should insert, right? I am doing the insertion.
Okay.
So let's make a new node here. Okay, I am making node. Let's say, what name of the node you want to give? Tell me. The root.
Head node.
Not head. Let's make a root only with some other name. Okay. I will be making a root node here. Okay. What data you want to give? The data we are already taking, right? With data, whatever data kept, I will pass it. Okay. This part is done. Then do what? Update my root. Update my root to be the root that I have made and return from here. And return from here. That's all. Okay, fine. If this is not mine, let's say if this is not my first node, what shall I do then? Tree is not empty. Tree is having at least some nodes inside it. What shall I do then?
So insert a second node.
Okay, tell me if the data I want to insert is greater than root.data, what shall I do?
Right insertion, right.
Right insertion. That means insert into the right subtree. Am I correct? Inside, go to the right subtree and with the same data. Am I correct? Yes. I think let's not do it here, but yeah, we'll do it in some other manner. Okay, else if data is lesser than root.data, what shall I do then? Tell me.
Insert root.left data.
Insert into the right subtree, that is root.left and data. This part is done. Now next, what shall I do? Else. Let's do not do anything. It will be automatically handled, else nothing will happen. This will go to its previous node. Okay, we will dry run it and you will get a more clarity.
सर वो फर्स्ट वाले इफ में रूट को रिटर्न नहीं कर रहे?
देख रहा हूं मैं कि यहाँ पे रूट रिटर्न करना सुइटेबल होगा या नहीं. Okay, let's do that. Okay, let's assign our root to be the new node that I am making and return the root from here. Okay, and return the root from here. Yeah, that's correct. Fine. Okay, then you have to do something like this. Return. Okay, the address of the entire root should be returned. Let's do one thing. Let's take our entire code below. Okay, so initially, let's say my root is at none. I don't have any root of the tree. Fine. And let's say I want to print the in order traversal of the tree. Can I do that? After inserting, I want to that right now how my root is looking like. I want to print the in order traversal. So let's do that also. In order of root. Whatever root I am having, let me insert some data inside it. Insert with root data 1. Insert with the root data 2. Insert with root data 3, let's say. Okay, sorry, these 3 insertions I am giving, and let's say I want to print, rather, how was my in order traversal was written? Total nodes in order of root. Let's call the in order of root from here after inserting 3. Okay, let's see whether we have our code are correct or not. Else has been done. Just wait.
सर प्रिंट नहीं करा
प्रिंट तो भाई ऑटोमेटिकली इन ऑर्डर से हो जाएगी ना, इफ आई एम नॉट रॉन्ग। इन ऑर्डर में देखो, अगर फंक्शन कॉल कर रहे हैं तो प्रिंट डॉट रूट डेटा हो ही रहा है। ठीक है, उसमें कोई टेंशन नहीं है। Any mistake we are doing, because it's not printing anything. Test.py, right? It's not printing anything.
So root none इसकी वजह से
नहीं, इसको रिटर्न नहीं कराते हैं, तब ये रूट का जो वैल्यू है ना बार बार चेंज हो जाएगा। इसको कराना जरूरी भी है टू एन एक्सटेंट। इसको एक तरीके से कराना जरूरी है, बताता हूँ क्यों। अगर मैं करूँ तो भी आंसर कुछ भी नहीं आएगा, दैट्स द थिंग। या okay, let's keep a temporary root. Okay, let's say let's keep another variable. That okay, this will be marking the root of the entire tree, and that is initially none. Fine, let's return root from here, and let's return from here. Right now, after the insertion part, okay, the insertion, if this is the root of my entire tree, let's do one thing. Let's keep it here. Okay, and let's check one thing. If the entire tree is not having any node inside it, if this is the case, mark root to be equal to none. Sorry, mark this route to be equal to my current route, and then return this route. Okay, fine. I think it should work now. Where is it? This.py. Referenced before assigned.
तो कैपिटल रूट वाला डिफाइन नहीं किया ना इसके साथ।
ये देखो तो ऑलरेडी हो गया है बाहर पे, कैपिटल रूट डिफाइन हो गया है। root equal to node dot data root referenced before assignment. Where is it? It work, man. I don't think it should have any kind of, yeah. One thing. Let's mark here after the insertion. Let's mark the value of root to be root. Okay, and the in order traversal we will be printing, we will be passing this root. Okay. Yet again, I guess nothing is happening. Any mistake you are able to figure out?
सर मैंने रूट वेरिएबल भी पास किया मगर कुछ आया नहीं आउटपुट।
यही बात है, आउटपुट कुछ नहीं आ रहा है। जबकि उसके इन ऑर्डर ट्रैवर्सल आना था, राइट?
मच्छर है। Okay, fine. Let's make a temporary node. Once my entire tree is empty, let's make a temporary node and return this temp as it is. Nothing else to do. Okay, fine. If this is the case, that okay, my entire route is empty.
सर दो में इन ऑर्डर वाला देखो ना।
See here. This is the in order traversal. This
सर
one.
इधर एक ही पैरामीटर पास कर रहे हैं ना मगर नीचे दो पैरामीटर डाल रहे हैं।
नहीं नहीं ऐसा नहीं है। इन ऑर्डर में देखो एक ही पैरामीटर दे रहा हूँ, रूट। इंसर्ट में दो पैरामीटर जाएगा ना, जो डेटा आई वांट टू इंसर्ट as well as the root. Okay, these two things will be necessary for insertion. or simply I can reduce the entire code to return node dot data that I want to insert. Okay. So now let's do one thing. If this is not the case, so what I can do is that root dot write will be equal to whatever will be returned as a part of this insertion. Else root dot left will be equal to whatever will be returned as a part of this insertion. And at the end, let's return the root. Let's return the root, whatever I have. Okay, let's try this. I guess this should work. This also doesn't work, so then we have to think something else. Fine, again, nothing is getting printed out. Shouldn't have been this case, man. Will be equal to this. Next, let's say root is storing the value should have been updated. Or let me try this also. Data, sorry. Okay, so that is an issue, right? That this is not the case, but this is the case. Am I correct? With our class, the data part is capital D, not a smaller d. So this was the case that I think was going wrong. Okay, it's coming correct. Is it? In order of will be 1, 2, 3. Will it be the case? If I insert 1, 2, 3, the in order will be 1, 2, 3 only. Am I correct?
Yes, sir.
What is my, if okay, let's say this is my root. Insert, no node is there initially, root will be here. A root will be here. Now next, if I insert 2, where it will be going? Here, right? 2. And if I insert 3, it will be going here. Okay, yeah. So let me change some data. Let me, okay, initially the first node that I will be inserting is 7. I will be inserting is 7, and let's say then 2, 3. So how it should look like? How it should look like? Okay, I haven't saved it, right? 237. Why I'm getting this data? If I print the in order traversal, why I'm getting this data? 237.
Left root.
The in order traversal of a BST is
Always gives sorted data.
always is sorted in ascending order. That's why we are getting the data. If I print the in order, I will be getting always sorted data as my result. Okay. So we are inserting successfully inside the BST. Fine. Okay. Let me simplify a bit the code. I guess that was not necessary. Okay. Yeah. Let it be. Okay. Let's have a dry run. Let's have a dry run of our current code. Okay, initially my root is none. Am I correct? Initially my root is none. That is, root is pointing to somewhere. None, that is no location inside my memory. Fine. Now what will happen? If data is greater than root dot data, what? Initially my root is none, and I want to insert data 7 into my tree, right? So, okay, let's call this insert root 7. What will happen? Who will tell? It has called for, okay, the root is this, insert this. It is initially pointing to none because nothing is there inside my tree. So I want to insert data that's value is 7 into the tree. What will happen? What will happen? If the function starts execution, what will happen? Is this condition true?
Yes.
Is this condition true? Okay, root is none initially, right? The first initial value of root is none. So is this condition true?
Yes, sir.
So what will happen?
The 7 becomes the root.
How it becomes? Means kya hoga? What will happen?
Because it was not existing any root now. That's why.
Okay, what do you mean by this? What do you mean by this? What do you mean by this? First tell me that.
सर अगर ट्री एम्प्टी है तो उसमें रूट डालने मतलब जो भी नोड हो
नहीं, पहले इस लाइन का मतलब बताओ. इस लाइन का मतलब बताओ. Somebody tell me what do you mean by this? What we have done so far using this?
सर नोड बना देगा एक डेटा का.
Is it, how many of you agree with Junaid that okay, if I write this, a node will be created with data. A node with data 7 will be created.
Yes, sir.
Yes, sir.
How many of you agree? Tell me here. How many of you agree? Only one. Rest?
क्योंकि सर नोड क्लास में 7 पास करेंगे जिसका डेटा बन जाएगा, लेफ्ट राइट नन रहेगा.
Exactly. It will make a node 7 and it will return this node to be pointed by root. Am I correct? Sorry, it is not. And it will what? It will do what? It will make a node and it will return this node where? Where it will return? Here. It will return here because the function has been called from here. This node once created will be returned here, and now root equal to whatever is returned by the function. That means okay, root will be now storing this node 7. Getting it? Root will be now pointing to this node. Getting it or not? Tell me that first. Getting it or not? Tell me.
Yes, sir.
Node has been created. It will be returned
Yes,
where?
sir.
From wherever it is being called, and now root will be storing its address. Get it? The entire objects on node's address will be stored by root. Getting it or not?
Yes, sir.
Only one is telling me, and rest are fine. This part is done. Now again see. Now again see, root equal to insert root 2. Insert inside the tree root 2. Okay, fine. Let's start executing this function. Let's start executing this function. What will happen? Let me call with whatever root I have. Now the root is what? Root is not none anymore. Root is not none anymore. Root is right now pointing at 7. Fine. Because I have updated that, okay, after the insertion of 7, whatever node I have, root will be pointing there. Fine. Now, okay, again, I want to insert 2. Let's go to the function. Now tell me what will happen.
First condition will be false.
Is it, how many agree with Saurabh that, okay, now first condition will be false. When I want to insert data 2 into the tree, this condition will be false. How many of you agree with him?
Yes, sir, I agree.
How many of you don't agree?
Yes, sir.
Okay, fine. Now next, if this condition is false, root is pointing to 7, it has some data. That means it has some address. It is not equal to none. So what will happen? This condition will be false. Let's go to the next condition. If data is greater than root dot data, is it true? Data
False.
is equal to root dot data. True or false?
False.
False, right? So
False is.
if this condition is false, what will happen? It will go here,
Elif.
elif Data is less than root dot data. True or false?
True. True.
Okay, true. What will happen?
Insert the left side of the root.
Okay, its left child was initially none, right? But yeah, root dot left will be assigned a value. Root dot left will be assigned a value, whatever will be returned by insert function root dot left data. Am I correct?
Yes.
Data is 2. Whatever will be returned by this function, that will be inserted, that will be stored into the root left of 7. Correct? Getting it? Getting it?
Yes. Yes, sir.
Okay, fine. So now, which is the most recent function I have right now? This insert function. Am I correct? So this
Yes.
one will be executed, then only the previous one will be executed. Okay. So let's start. This is a new function. Let's start its execution from the beginning. Again, see. What is the root left of 7? What is the root left of 7? So this root left will be storing, root left of 7 will be storing whatever will be returned by this function. What is the root left of 7 I have? What is the value of root left of 7? None. Am I correct? Am I correct? That okay? Since 7 was not having any child node, the root left was storing none inside that. Am I
Yes.
correct?
Yes.
So, okay, none has been passed. The value none has been passed into the insert function. So again, for this, is it true?
True.
For this function, is this condition to root equal to none, return node dot data. Node data. What will happen? Who will tell?
Node create होगा और उसको assign
A
होगा.
node will be
value
created. Node will be created. With data 2 will be created. And that this will be returned where?
root dot left.
Root dot left of 7. Getting it? Now root dot left variable. This pointer will be storing address of this node. Getting it? This node has been created, returned where? Into the root left of 7. Getting it? Getting it or not? Tell me that.
Yes, sir.
Okay, now the root left of 7 is storing 2. Fine. Now I am here. I am right now at the function call of, I am right now at the function call where 7 was my root. This part is done. What will happen? This part is done. What will happen? Return the root. Return the root. Where this root was pointing at 7. So will there be any change to the root?
No.
No, right? Because for the function call node of 7, the root was at 7. That is only getting returned. So root will be storing that. No problem at all. Getting it? Let's have another. Let's have another insertion dry run, and you will be able to understand better, I guess. Okay, let's root equal to insert root 3. Initially, where my root is pointing at 7, right? This is where my root is pointing. So what I call insert from root 7, insert this 3. Getting it? Okay, now start. Root equal to none, true or false?
False.
What will happen then? Data greater than root dot data, true or false?
False.
So data lesser than equal to root dot data, true or false?
True.
True. True, right? So what will happen? It will call what?
Insert root.
It will do what? Inside the root left. Inside the root left, it will be storing whatever will be returned by the insert function of what? What is
Root
the
dot
left?
C.
What is the left child of 7?
2.
2. And what is to be inserted? 3. Fine. Okay. Now tell me, this is a new, most recent is this one. As per the laws of recursion, I have to execute this first, then only I can execute this part. Fine. Okay, this is a new function. Start execution from the beginning. If root equal to none, return node. This is true or false?
False.
False. Okay. Data greater than root dot data. True or false?
True.
True.
Then what will happen? It will inside root dot write of 2. Root dot write of 2 will be storing what value? What value it will store? Whatever will be returned by the insert function of what?
Insert root comma 3.
Insert comma root
Root
dot
com-
write.
हाँ,
So
root
what is
dot
the root dot write of 2? What is the root dot write of 2?
none.
None.
None. And what is to be inserted? 3. Okay. New function. Let's start the execution from the beginning. Root equal to none. For this function call, is this condition true?
True.
So what will happen?
Node
Return
create.
node data. Create a node. Create a node with data 3 and return it where?
Root dot write.
Towards the inside the root dot write of this function call. Insert 2, 3. Okay. So, okay, this 3 is being stored where? Inside the right node of 2. Getting it? Inside the right node of 2, this 3 will be created and will be stored. Fine. This part is done. So this is basically, okay, yeah. This root dot write is basically storing node with data 3. Okay, fine. Okay, this part is done. This part is done, right? For this function call, this part is done. Data greater than root dot data is done. Will this be executed? Will the elif part be executed?
No, sir.
Okay, so return what? Return what and where it will be returned? What is the root here? Inside this function call, what is the root?
So 2 is the root.
So 2 will be again returned where? Inside the root left of the previous function call. So what does the root left is storing? What does the root left is storing? For root 7, what does this left child of 7 will be having? 2 as its child. Okay. So no change in the left child of 7 is there. So again, what is the root here? For this function call, what is the root 7? That will be where? This 7 will be returned to be stored inside the original root. Okay. So no changes to the root variable as well. No problem. Getting it? Tell me that.
Yes, sir.
That yes, if any new node is to be made, that will be then any of the left or right child will be updated. But yeah, no changes to the previous childs or to the previous level nodes links will be there. That's the thing. Tell me that. Is it clear? Is the insertion part clear or not?
Yes, sir.
Very small dim answers you are giving with low voices. What shall I assume?
Yes, sir.
Little bit of recursion also getting clear with the examples that we are taking. Tell me that first. That how recursion is working.
Yes, sir.
Yes, sir.
With practice only and more, I think once we will come to the DP recursion, more you will be seeing recursions. Okay. Okay,
DP
fine.
what?
Dynamic programming. DP, actually these recursive approaches are very bad approaches. Not for every problem, but for majority of problems. Recursion gives very bad approaches. So for optimizing those things, we use extra spaces. Okay, we use extra space. We utilize some of the space complexity to optimize our time complexity of the problem. You will be getting those problems inside the dynamic programming. That's a very vast topic, dynamic programming. Okay.
When will it start?
After a few classes. Just wait. And that will be the end of our, that will be marking the end of our data structures and algorithms.
So how many days are left?
Very few days.
So
तो DP के लिए आप
1
रहोगे
month?
ना?
DP, not even a month, I guess. Yeah, approx a month. You can say I will be there, but yeah, almost our syllabus will be finishing in a few days. Okay, let me show you. Let me have another insertion here. Let me, I want to insert 8. I think you will be getting some projects also. Okay, till the time I am here. And yeah, before, after the day DSA is over, data structures and algorithms will be over. We will be seeing into the core CSE part. Some of the core CSE part we will see. And yeah, so okay, is the still in order traversal correct? 2378. It will be sorted, right? So we are, every time we are running the in order traversal, we are getting the in order traversal to be sorted only. Okay, so what was our tree? 7, 2, 3. Okay, let's insert another object 8. Fine, let's insert another object 8. Fine. Okay, fine. So okay, let's call this. This is a insert root. Insert from the start from the root and insert the root. Insert a node with data 8. Okay, let's start. Okay, fine. I start from here. Root equal to none. True or false? I called for the function insert.
So false.
Insert from 7. Start seeing from 7. And yeah, insert this data 8. False. This part is false. If data greater than root dot data, true or false?
True, sir.
So true.
So what will happen? Root dot write. Whatever 7 right child of 7 will be storing what? Whatever will be returned by the insert function that is called on root dot write. What is the root dot currently? What is the value of root dot write? I have none. So this value will be passed here. Okay, that okay. Right now, the right child of 7 is having none, no value. And I want to insert 8 into the tree. Okay, fine. So this is a new function.
Hello.
हेलो भाई, कोई व्हाट्सएप ग्रुप है क्या? हेलो.
Yeah, bro, है.
व्हाट्सएप नंबर दिया है चैट में. निशांत भाई मैसेज कर दो व्हाट्सएप पे, मैं लिंक दे दूंगा आपको.
ओके ब्रो.
Sorry, I got disconnected for a while. Okay. Actually, some kind of internet issues from my end. I don't know. All of a sudden has arrived. So let's start. Okay. Now tell me. Insert none 8. What will be happening here? Insert none 8. Insert function is called with values none and 8. So new function execution will start from the beginning. Root equal to none. Is it true or false?
So true.
So what will happen? What will happen? New node will be created with data. New node with data 8 will be created, and that will be passed where? This will be passed to the root 7.write. Whatever was the value of the right child of 7, this pointer, that will be updated with the address of 8. Getting it? Whenever this will be returned, this 8 will be, node 8 will be made, and this will be returned to the right child of 7. The address of node 8 will be passed towards the right child of 7. Done. This function has completed after returning. So, okay. This function has completed. Fine. Now tell me, once I am inside this function, this call was made, will the elif be executing? Will the elif condition be executing?
No,
If
sir.
is done, so if this will be skipped, right? Now return the root. That means I am inside this function call. What will be returned? What will be returned? Which one is the root inside this function?
7.
What is the value of 7?
7.
7, right? So, okay, what will be returned here? What will be returned here? Root equal to insert 7. In the root equal to insert root 8. Whatever is the value inside this node, its address will be passed, and root variable will be storing that, nothing else. That means this root, whatever root was previously storing the 7, even after inserting also, the root is storing the address of 7 only, no changes. So no need to worry. That's all.
सर रूट तो सेम ही रहेगा हमेशा.
रूट, हाँ, इसीलिए तो हमेशा क्या है, जो रूट का ओरिजिनल वैल्यू है वही रिटर्न हो रहा है. ठीक है, तो वो टेंशन लेने की बात नहीं है. Are these points clear? Tell me. The insertion code that we have taken today.
Yes.
Yes, sir.
All of you.
Yes, sir.
As well as whatever problem regarding the left view I have told, please practice that. Please come up with the code. If you don't come up, at least 10 people don't come up, I won't show you the code tomorrow. Because now the time is coming for your interviews. You should gear up. Yeah, tell me. Okay, let's take the MCQs and then we will wrap up. Okay, one more BST problem we will discuss tomorrow, and then we will start with heaps. Two things we will see tomorrow: searching in BSTs, as well as a problem related to BSTs, and then we will start with heaps. Okay. Then we will start with heaps. Probably, yes, probably this week is the last week for our data structures and algorithms. And yeah, next week one class will be there. And then we will be starting with some core CSE topics, operating systems, networking, these are all the things you will be seeing. Okay. So yeah, I think 3 months it has been almost that I have been teaching you.
Yes, sir.
Yes, sir.
और कुछ दिन रह गया, सह जाओ.
सहना क्या है सर इसमें?
बार बार ऐसा बोल के क्या बताना चाहते हो आप?
आपके फीडबैक जो मिलते हैं कभी कभी,
टॉर्चर कर रहे हो क्या सर आप?
इसका जवाब देता हूँ और क्या करें. बाप रे. अच्छा एक बात बताओ, कभी जेन्युइनली लगा कि मैं टाइम वेस्ट कर रहा हूँ, समथिंग लाइक दैट? बिकॉज आई हैव गॉट सच फीडबैक्स आल्सो. I mean, these things were shocking. How many of you think I waste time inside the class?
No,
Tell
sir.
me then I have to think of it something.
सर एमसीक्यूज दे दिए क्या आपने?
दे रहे हैं, अभी दे रहे हैं, ठीक है,
ओके सर.
फाइन. या गिवन इट, फर्स्ट MCQ given. Okay, the expected answer of my last question, third question given is wrong. Please, whatever you want to mark, you can mark there. Mark true, everyone. For the third question given, mark true, everyone. The expected answer is wrongly marked there. Okay. For the third question. Okay, yeah, all the questions are done. I've created the attendance for all of you. Please mark the attendance. Yeah, who is having doubt? You can ask.
हेलो सर।
Yeah, tell me.
सर आप एक बार प्रोग्राम बता सकते हैं कि मतलब लूप के थ्रू ऑब्जेक्ट कैसे बनाते हैं?
ठीक है, मतलब कितना ऑब्जेक्ट बनाना चाहते हो वैसे करते रहो, यही बात है। बट फिर लिस्ट ऑफ ऑब्जेक्ट्स बनाना पड़ेगा, समथिंग लाइक दैट। ठीक है, वरना तो फिर एक ऑब्जेक्ट को लिस्ट में इंसर्ट करना पड़ेगा, ऐसा कुछ करना पड़ेगा। लेट्स से,
So I have one question to
या
ask.
टेल मी।
So I have to share the screen. I have solved it, but there is a problem coming. It's not getting,
Okay.
it's not giving the right output.
Okay, yeah, show me the question. Share the screen. Given the permission already, share the screen.
So is it visible?
Yeah, it's visible.
Yes, so this is the question.
What was the question?
So this is the question.
If the tree are same or not.
Two trees are given, we have to find both are identical or not.
See here, this is not the way of doing this. Okay. Yeah, these three conditions are correct. That okay. But yeah, if at the end you are seeing that, okay, if both of them are none, return true. Very, very correct. If any of them is existing, root 1's left is existing. Yeah. Else what you have to do is that return false. Else check the condition. If root 1 dot, how we have declared data here, root 1 dot data. If this is equal to if this is equal to root 2 dot data, then do one thing. Return from here whatever we will be getting. Let's keep some values here. Okay, Boolean values. Let's see. Check for both the subtrees. Answer 1. Let's say, are the subtrees of root 1 dot left, sorry, are the subtrees of root 1 dot left and root 2 dot left equal? Is it true? As well as keep another variable, answer 2. Are the subtrees root 2 dot right and
ये कर लो।
these are the right subtrees of again both the trees are equal or not? Just see them. If any one of them is false, return false. If answer 1 is false or answer 2 is false, then do what from here? Return false. Else if this is not the case,
and return true. Some kind of indentation issue will be there.
एल्स पार्ट में सर इंडेंटेशन एरर आएगा पूरा.
Else नहीं आएगा इसमें. अभी यहीं से true return कर सकते हो.
नहीं, जो एल्स पार्ट है ये जो अभी आप सब रूट वाला लिख रहे हो, इसमें पूरे इसमें इंडेंटेशन एरर है.
वही ठीक कर लेना. Same tree. Else check for the same left subtree and right subtree part. Both should be equal. And if this is equal, okay, fine. Else check here. If the data of my current nodes are also not equal, then I can say that okay, return false from here. That's all. Nothing else is required. Okay. Correct the indentation after the code. या पूरा indentation error तो है इधर पे. This part is not required, I guess. Now try running this.
So it's giving nothing.
Able to print anything here? Have you printed anything? From where have you called the function? Function calling is not here, right? You haven't called the function even. Made two trees, right? Which one are them? But why you have made a single tree? That's what I'm able to see. You have made a single tree and then assigning the root to be on the same tree, root 1 and root 2. Make different trees. And yeah, even if you do them, I think you'll be getting the answer here. Okay, do it. Then I will see tomorrow.
Trees are identical actually. So I just created two roots and the datas are same. That's why I didn't create it again.
Yeah, that's not an issue. Even if you haven't called the function, right? Then how can it print something? You should call the function first. What is it? What was the function?
Same tree.
Print same tree, root 1, root 2. Call it. Print same tree, root 1, root 2. True, you're getting it. That is now coming to be true, I guess.
Yes, sir. But sir, that code maybe that was not working because I didn't call that.
Maybe it can happen. Try using that.
Yes, sir.
Yeah.
Because sir, I took some logic in doubt session. They gave me some logic. They helped me. Then I tried to run that this code.
Okay.
But maybe I haven't called that. That's why maybe it's not working.
Okay, may happen. Yeah. Is
Okay,
it
sir.
done?
Got it now. Yeah. Thank you.
Yeah. Yeah, Mahesh, tell me.
आप बता देते कैसा बना.
को महेश का कुछ प्रॉब्लम आ रहा है. I can't copy my file from PyCharm to local repo by using gedit command in the terminal. And Mahesh is here. Has he gone? Mahesh is here. I need to see your machine. What is happening? Are you able to share that? Share your screen. लगता है महेश चला गया। हाँ बताओ कौन सा, क्या इब्रार? हेलो
यस सर।
कुछ पूछ रहे थे? जुनैद पूछ रहा था या तुम पूछ रहे थे?
नो सर, मैंने नहीं पूछा।
जुनैद। हेलो सर।
हाँ
आप बता रहे थे ना कि लूप लूप के थ्रू कैसे ऑब्जेक्ट बनाएंगे।
ठीक है, देखते हैं चलो। दिख रहा है? कुछ ऐसा कर सकते हो, लिस्ट रख सकते हो एक, ठीक है। और लेट से मैं यहाँ पे क्या ऑब्जेक्ट बना रहा हूँ, कितने ऑब्जेक्ट्स बनाने हैं? फॉर आई इन रेंज लेट से 5 ऑब्जेक्ट बनानी है, ठीक है। क्या करो, जैसे अभी मेरे पास नोड्स बनाने हैं, ठीक है। एल डॉट अपेंड लिस्ट है, उसमें अपेंड करो नोड ऑफ लेट से आई, ठीक है। एंड देन प्रिंट द लिस्ट, देन प्रिंट द लिस्ट। ऑब्जेक्ट्स की लिस्ट ऐसे हम बना सकते हैं। दिख रहा है? 5 ऑब्जेक्ट बनाए, सारे की एड्रेसेस मिल जाएंगी कहाँ कहाँ पे है। प्रिंट करना है तो वो भी कर सकते हो, फॉर आई इन रेंज लेंथ ऑफ एल, राइट, ये भी कर सकते हो। प्रिंट एल ऑफ आई, दैट्स ऑल। प्रिंट एल ऑफ आई डॉट डेटा।
इंडेंटेशन नहीं दी।
इज इट इंडेंटेशन है?
प्रिंट के बस।
हाँ ठीक है, देख लेते हैं।
तो 1 2 3 4 दिया, 0 1 2 3।
सही है, ठीक है। 0 1 2 3 4 5 है, 5 ऑब्जेक्ट है, उसमें डेटा बना दिया।
समझा सर, थैंक यू।
या चलो, थैंक यू। Any more doubts anyone is having? अच्छा, और तुम लोग में से कौन है जिसने ये दिया था, क्या कहे, रिटेस्ट दिया था, और वो कैसा हुआ? भाई बार बार पिन ड्रॉप साइलेंस ना रखा करो यार, ऐसा
So
करोगे।
I wanna ask something.
या टेल मी।
So I have to share my screen.
या शेयर इट।
सर टेस्ट मतलब मैंने रिटेस्ट नहीं किया था, पहले टेस्ट किया था सर। लोग ने पूछे थे लैम्डा फंक्शन क्या होता है, पता है क्या?
लैम्डा, अच्छा लैम्डा फंक्शन एक्चुअली थोड़ा एडवांस काइंड ऑफ फंक्शन होता है, ठीक है। एक लाइन का अगर कोई फंक्शन लिखते हो जिसमें सिर्फ एक, चलो मान लो रिटर्न स्टेटमेंट है, ये है वो है, उसको रिड्यूस कर सकते हैं एक लाइन। फंक्शन ना लिख के क्या कर सकते हैं, एक लाइन में लैम्डा लिख के उसको डिफाइन कर सकते हैं, ठीक है। ठीक है, डिस्कस कर दूंगा मैं ये लैम्डा फंक्शन का, बात नहीं किया क्योंकि कंफ्यूजन करेगा ये, ठीक है।
बट हर जगह पूछता है सर लैम्डा फंक्शन क्या है।
तुम लोग के नॉलेज के लिए पूछता है, तुम लोग को
हाँ।
रेडी होना है इंटरव्यूज के लिए, ठीक है, इसीलिए पूछता है।
ये सर एक क्वेश्चन था, उसमें लैम्डा फंक्शन यूज करके एक लाइन में ही डिक्शनरी को सॉर्ट करके टपल में चेंज कर दिया और उसको फिर सॉर्ट भी कर दिया रिवर्स में।
तो मैंने
वही
अगर
पूछा था कि
ठीक है, वो हो जाएगा, वो कोई प्रॉब्लम नहीं है। पर हाँ, अगर मैं बोलूंगा तो लगभग आधा घंटा 45 मिनट्स लैम्डा के पीछे देना पड़ेगा, यही प्रॉब्लम है। चलो ठीक है, किसी दिन ये एक्स्ट्रा डाउट सेशंस में इसको लेते हैं, लैम्डा फंक्शन को क्या चीज होता है, ठीक है। बताओ क्या प्रॉब्लम है।
सर ये वाला जो क्वेश्चन है,
रिटर्न द के मोस्ट फ्रीक्वेंट एलिमेंट्स। अच्छा ठीक है, बीएसटी पढ़ा है, ट्राई करो इसे। आज का कब का क्वेश्चन है ये?
सर ये असाइनमेंट का क्वेश्चन है, जो आपने अभी रिसेंटली दिया था
ये
Sunday
BST
को।
से बनेगा, BST से बनेगा।
BST से ही। फिर
BST
सर
यूज
इसमें तो
करेंगे।
एरे यूज हो रहा है बस।
एरे है ना, एरे को मैं मतलब क्या करूंगा एरे में, के मोस्ट फ्रीक्वेंट। अच्छा ठीक है, ये क्वेश्चन है ना।
हाँ सर, इसी क्वेश्चन में ना लैम्डा यूज किया है। मैंने उसका सोल्यूशन देखा था, जो आता है ना सोल्यूशन देते
हैशिंग से
हैं।
कर दो इससे, हैशिंग
हाँ
से।
हैशिंग से, फिर टेबल में चेंज किया और उसके बाद उसको सॉर्ट कर दिया, तो उसमें कुछ लैम्डा यूज किया उन्होंने।
ठीक है, वो लैम्डा ना यूज करके
समझ
भी
नहीं
बन
आया।
जाएगा, लैम्डा ना यूज करके भी बन जाएगा, नो टेंशन। ओके फाइन, ये कब का है असाइनमेंट्स, कब खत्म कब हो रहा है?
सर हो चुका होगा या फिर थोड़ा आधा घंटा बचा होगा, खत्म ही होने वाला था।
ठीक है फाइन, कल देखता हूँ अगर पॉसिबल हो पाए तो। पर यार यही है, डिस्कस करेंगे, बहुत देर लगेगा ये प्रॉब्लम्स।
सब
लैम्डा डिस्कस।
क्वेश्चंस करेंगे ना तभी क्वेश्चंस, दूसरे क्वेश्चंस कैसे करने हैं उसका आइडिया लगेगा। कोई क्वेश्चंस ही नहीं करते तो हमें हर क्वेश्चन नया लगता है कि
सर
इसमें
ये
क्या
वाला
होगा।
मैंने किया।
कानून ने किया है। ठीक है चलो देखते हैं ये कब सॉल्व कर पाएंगे, कर देंगे। ये कोई
न्यू
नॉर्मल सा
टॉपिक से
प्रॉब्लम
पहले
है,
एक बार देख लेना।
ये नॉर्मल सा प्रॉब्लम है, इसमें कुछ नहीं है। लैम्डा, विदाउट
सर
लैम्डा थिंक ऑफ इट, कैसे कर सकते हैं?
सर
लैम्डा
कोड भेजूँ
जरूरी
आपको?
नहीं है ना। हाँ क्या? हेलो।
हाँ सर मैंने ट्राई किया था ये।
कैसे किया?
सर मैंने क्या किया मालूम, एक पहले लिस्ट बनाया और एक डिक्शनरी बनाया।
ठीक है।
फिर
फिर
सर उसमें सर उसके सर मैंने एरे लिया जो जिसमें हम लोग ने वैल्यू पास की ना स्टार्टिंग में 1 1 2 2 3, उसको फ्रीक्वेंसी मेथड में पास किया और आई लुक के थ्रू एरे चेक किया, और अगर वो नहीं है तो मैंने इसके अंदर डिक्शनरी के अंदर ऐड किया और 1 वैल्यू दिया उसकी।
ठीक है।
और अगर है तो वो जो 1 को इंक्रीज एक और करो 2 से।
अच्छा इसको एक और तरीके
वैल्यू
से,
इंक्रीज कर दो।
दैट्स अ थिंग मैन। फर्स्टली यहाँ पे प्रॉब्लम आता है कि तुम्हारे यहाँ पे जो डिक्शनरीज यूज होते हैं उसका इम्प्लीमेंटेशन थोड़ा अलग है पाइथन में, थोड़ा अजीब काइंड ऑफ रादर।
सर मैं स्क्रीन शेयर करके बताऊँ?
अभी रहने देते हैं, टाइम भी ऑलमोस्ट ओवर होने वाला है। ठीक है मैं कल देखता हूँ इसे, बता दूंगा कैसे करना है, वो कोई टेंशन नहीं है।
सर बस
आंसर आ रहे
लॉजिक
ना तुम?
तो सर एल्गो बता दो बस कि इस तरह से कर सकते हैं।
देखो क्या कर सकते हो, 2 डिक्शनरीज का यूज कर सकते हो, फिलहाल तो मैं लैम्डा पे जा नहीं रहा। ठीक है
सर देखो मैंने आपको भेजा कोड।
जी फाइन, फ्रीक्वेंसी फाइन, ठीक है वो तो टेंशन नहीं है। फ्रीक्वेंसी, रिटर्न फ्रीक्वेंसी 0 2, या क्या, ये क्या चीज है 0 to 2?
सर वो जो स्टार्टिंग की जो 2 सबसे ज्यादा फ्रीक्वेंसी रहेगी ना वो रिटर्न करने का है।
कुछ गड़बड़ लगता है इसे, क्यों 2, क्यों 2 ही को क्यों करेंगे?
देखो के की वैल्यू 2 है इसलिए के
अच्छा
की वैल्यू
वो
जितनी भी
ठीक है,
होगी। हाँ
वो ठीक है, बट उसमें के मेंशन होना चाहिए ना, के तो कुछ भी हो सकता है।
सर के की वैल्यू गिवन है ना, क्वेश्चन में के की वैल्यू गिवन होगी, जितनी गिवन होगी उतने ही एलिमेंट्स का।
क्वेश्चन में एग्जाम्पल का वैल्यू गिवन है, डजंट मीन कि क्वेश्चन चेंज नहीं होगा। के
सर
तुम
वो
इस पे
इनपुट लेके फिर एंड में +1 दे दूंगा ना।
ठीक है, बट वहां पे 2 के जगह के रखो, ठीक है?
हाँ सर।
ठीक है सर, के की वैल्यू अगर 4 होगी तो हम 4 एलिमेंट्स को रिप्रेजेंट करेंगे फिर।
बिल्कुल, तो इसीलिए तो वहां पे मैं कुछ भी हो सकता है ना, के क्या वैल्यू, के क्यों रखूं, तो मैं 2 और 4 क्यों रखूं, पहले से के रखेंगे उसकी जगह पे।
यस सर।
में क्या कर सकते हैं यार, ये भी बंद हो गया।
सर ना टपल में फिर उसको कन्वर्ट कर दिया था डिक्शनरी को, के बाद फिर सेकंड एलिमेंट प्रिंट किया।
ठीक है एक काम कर सकते हो, देखो इधर पे पहले डिक्शनरी में स्टोर कराओ कि कौन कितनी बार, हाउ मेनी एलिमेंट्स जो है पर्टिकुलर एलिमेंट टी कितनी बार ऑकर हुआ है, लेट्स से x टाइम्स ऑकर हुआ है। ठीक है फिर क्या करो, डिक्शनरी में रख लिया कितने E F G, जितने भी एलिमेंट्स है x y z टाइम्स ऑकर हुआ है, मुझे मिल गया डिक्शनरी में। फिर क्या करेंगे, ये बनाओ, लिस्ट बनाओ। लिस्ट में इसमें बनाओ x टाइम्स ऑकर हुआ है, कौन सा एलिमेंट t, बना दिया, ठीक है। y टाइम्स ऑकर हुआ है, कौन सा एलिमेंट है, f है। z टाइम्स ऑकर हुआ है, कौन सा एलिमेंट है, z टाइम्स ऑकर हुआ है, कौन सा एलिमेंट है, g। ऐसे टपल्स बना लो, लिस्ट के अंदर टपल बना लो, और फिर इसको सॉर्ट कर दो, डिसेंडिंग ऑर्डर में, ठीक है। और डिसेंडिंग ऑर्डर में सॉर्ट किया, डिसेंडिंग ऑर्डर में जो सॉर्ट किया एज पर द फर्स्ट एलिमेंट, नॉर्मल सॉर्ट मारो। नॉर्मल सॉर्ट फंक्शन जस्ट डॉट सॉर्ट फंक्शन यूज कर दोगे तो फर्स्ट एलिमेंट के अकॉर्डिंग सॉर्ट कर देगा, फिर फर्स्ट के एलिमेंट्स प्रिंट कर देंगे, ठीक है। इसमें ज्यादा कुछ नहीं है, कल कोड बता दूंगा कैसे करते हैं एंड ऑफ द क्लास में। हेलो,
डिक्शनरी से टपल में चेंज करना है, ये लिस्ट
डिक्शनरी में
में
जो,
चेंज करना है।
हाँ, लिस्ट में टपल्स रख लो, लिस्ट में वैल्यूज ऑफ टपल्स रख लो। फॉर ईच एलिमेंट कितनी बार ऑकर हो रहा है उसको टपल्स में चेंज करके, पहले वैल्यू, नंबर ऑफ ऑकरेंसेस और कौन सा एलिमेंट है, इस टाइप के टपल बना लो, पेयर्स बना लो, और उसको एक लिस्ट में इंसर्ट कर दो और डॉट सॉर्ट फंक्शन कर दो उसमें, वो सॉर्ट हो जाएगा एज पर द नंबर ऑफ ऑकरेंसेस। फिर क्या करना, ये करना, फर्स्ट के एलिमेंट्स को प्रिंट कर देना, दैट्स ऑल। इसमें ज्यादा कुछ नहीं है
सर। पहले डिक्शनरी से हमें चेंज करना है लिस्ट में,
फिर लिस्ट को सॉर्ट कर दो और फिर उसका फर्स्ट के एलिमेंट्स प्रिंट कर दो, आंसर आ जाएगा।
और सर लिस्ट में जो एलिमेंट्स होंगे वो टपल के फॉर्म में होंगे।
हाँ, वो टपल के फॉर्म में होंगे। फर्स्ट नंबर जो टपल होगा उसमें पेयर्स होंगे, फर्स्ट नंबर होगा जो पेयर का वो नंबर ऑफ ऑकरेंसेस, दूसरा नंबर कौन सा एलिमेंट है वो, ठीक है, आ जाएगा। इसमें लैम्डा को स्पेशलाइज्ड यूज करने की जरूरत नहीं है, शायद दिया है ताकि तुम
तो
लोग
वही
थोड़ा
तो पता नहीं
रिसर्च
क्या
कर लो
कोड
कि,
करें जो डिक्शनरी।
ठीक है, वो कल दे दूंगा मैं, डोंट वरी ऑन दैट, ट्राई ऑन दैट। आज जो मेथड दिया उसमें ट्राई करो, थोड़ा सोचना कि क्या हो रहा है।
ओके सर।
ओके फाइन, गुड नाइट ऑल ऑफ यू।
गुड नाइट सर।
गुड नाइट।
गुड नाइट सर।
गुड नाइट। और सौरभ,
यस
क्या हाल है?
एकदम बढ़िया, मस्त मजे में।
चलो, अब तो फिर एग्जाम आएगा ना कुछ दिनों बाद, 2 हफ्ते बाद।
हाँ, फिर से आप रिवीजन नहीं करवाओगे?
ना, करा देंगे, जितना हो सके करा देंगे इस बार।
और
चलो,
फिर से स्कोर कम आएगा।
अरे यार नहीं आएगा, स्कोर का ना सोचो यार, इतना स्कोर तो बढ़ते कमते रहता है। कॉन्सेप्ट अगर क्लियर है यू विल बी एसिंग एवरीथिंग, उसमें कोई बात नहीं है।
नहीं, स्कोर मैटर करता है सर।
थोड़ा बूस्ट मिलता है कॉन्फिडेंस में, ये बात तो मैं भी एग्री करता हूँ।
बस
या चलो सही, इस बार देखते हैं, अब तो
हाँ,
और कुछ दिन है।
एक दो दिन पहले अगर सब स्किप करके हम लोग रिवाइज करें तो ज्यादा बेटर है।
बट स्किप नहीं कर सकते, ये भी एक बात
थोड़ा
है।
थोड़ा समय।
ठीक है, चलो ट्राई
हम
करेंगे।
फास्ट पे बहुत चल रहे हैं वैसे, एक टॉपिक का हम क्वेश्चंस प्रैक्टिस नहीं कर पाते, दूसरा टॉपिक स्टार्ट हो जाता है, फिर टॉपिक रह जाता है पिछला वाला।
वही इसीलिए मैं कहता हूँ कि डाउट क्लासेस में आया करो, ताकि मैं थोड़ा अच्छे से प्रॉब्लम्स डिस्कस कर दूं, ट्रीज वगैरह का, लिंक लिस्ट का, जैसे अच्छा बहुत प्रॉब्लम्स, 4-5 प्रॉब्लम डिस्कस हुआ है हमारा। ट्रीज का भी जैसे आज भी लेफ्ट व्यू वाला लिया, ट्रीज का बताया था एक और प्रॉब्लम ऑन द डाउट क्लास। कौन सा था डाउट क्लास में जो प्रॉब्लम बताया था?
सो वो रिवर्ट वाला, मिरर इमेज वाला,
मिरर
tree
इमेज
का।
वाला, अच्छा वाला प्रॉब्लम था, पूछता है इंटरव्यूज में ये सब। और कुछ
सर फिर टॉप व्यू में भी आएगा ना प्रॉब्लम?
ये तो अगर ये लेफ्ट और राइट व्यू निकालना सीख गए ना तो टॉप व्यू कर लोगे खुद से, ठीक है, कोई प्रॉब्लम नहीं है इसमें। बस कल कोड करके आना कि मैं कैसे कोड करूंगा, इसको सोच के आओ। इफ यू आर नॉट एबल टू, नो वरी, ट्राई, एटलीस्ट ट्राई तुम्हें करना ही होगा। अब मैं भी पुश करूंगा धीरे धीरे इधर से, अगर खुद से कोड नहीं करते इंटरव्यूज में प्रॉब्लम होगा, ठीक है।
अब सीएसई कब से चालू करोगे?
कुछ दिन, अगले मंडे नहीं, अगले ट्यूसडे से तुम्हारा ऑपरेटिंग सिस्टम चालू हो जाएगा, अगले ट्यूसडे।
ठीक है, मतलब फिर ये सब खत्म हो जाएगा।
हाँ चलो,
फिर हम
थोड़ी
जैसा
सा
बुरा फिर हम जैसा बुरा टीचर भी चला जाएगा और नहीं पढ़ाएगा।
नहीं, थोड़ी शांति
नहीं
से
सर।
चलो ठीक है, चलो गुड नाइट। हाँ
गुड नाइट, गुड नाइट।
Good night, sir.
गुड नाइट।